Another video for class 1. Now, I made this last year. I decided to try to make this an in-class assignment, and because I figured I might as well have you guys start doing one. Do your best at the thing, work it through. It takes up a lot of class time. I'm not sure I'll do it. We'll have to make the decision. I guess it's another 3 classes starting in about 3 weeks. We'll make the decision when we come to it. But here I'll do the solution to it, although I think I might have done this last year. I did the solution to it last year. I think so. But let's see. Let's see what happens. All right. So anyway, this is a problem that is out of Philpott. So give him credit for the fundamental part. But we want to find the moments, the equivalent forces and moments, and draw them onto this little stump by way of doing 3 views. Right. So it's a little bit more challenging, right, when you have 3 views of something. And I ought to make this in SolidWorks so that you could see it rotated. That would be a good idea. Maybe. So anyway, let me go to the camera. Okay. All right. So here's the sheet right here. And so what I want to do is to draw 3 views of the thing. I want to be careful when managing your paper to try to keep the, try to be neat, and you want to get your equations like located near your drawing and they're associated with it. It's a really good idea to like use a straight edge. So I'm going to start with my XY right here, I think. So the creepy eye is looking this way right here. Creepy eye is looking at that X and Y. And so I'm going to see this part of it right here. And I'm going to draw this, and I'll give it some depth right there, right? So this is going to be I'm going to label it, call it an FBD. I'm going to label what my axes are going to be, X and Y. And somewhere down the length of it, you can see that it's a little bit longer there than it is there. We have a circle, so I'm going to freehand it right there. There's a circle right there, and then we have this vertical post that's going in the Y direction. So we'll write that onto there. Okay. And let me put the forces on there first, and then I'll put the dimensions. So you see we have 370 pounds coming down. 370 pounds. That 220 is coming out of is going into the page. At least for us, it's going in the Z direction, so we can't see it. But that 180 is in the positive X. So 180. I said 180, but I went 190. All right. So here is where we care about, right? That's the section of interest right there that contains H and K. So I will I'll put the dimensions that have to go to right there. So I'll just put a little line right in there. And so the dimension that I have, and maybe I should have left a little marker. There we go. That looks to be 5.6 inches. I'll use an inch symbol. I like to make the dimensions like a little bit lighter if I can remember to do it. And let me draw like a little guideline. There's a center line that's onto here, and that distance is the 2.5. Right, so I'll put the 2.5 inches in there, and then I'll draw this, and then maybe I'll put little arrowheads. Now I've got the thing started, but I need to put the reaction forces that are going to happen onto this. Hey, there you go. And so we have reaction forces, and I'll put the arrowhead that direction right there. And so that's going to be RY. And then this guy is going to the right, so this guy must be going to the left. I'll go R, and that's going to be X. Now, this force is causing a clockwise motion, right? This force is causing a clockwise motion. So if we're going to look at the reaction, I like to draw that arc and then start thinking my way through it. If this is clockwise and that's clockwise, this has to be counterclockwise. So I'll call this M. And there's K and an H right there. I don't know what to call this thing. Let's just pretend that there's no H. And we'll just call it K, just to give it a subscript, right? And this is about the Z, right? So I just want to make it, it's a specific point, it's a specific moment. And so if we have the sum of the moments about the Z axis, which is what we have when we have this right here. When we have the XY direction, it's the Z axis we're doing moments about. We'll put in the MKZ. That's the moment we're going to care about. And then this is going to be minus 370, times 5.6. And then we have also minus 190 times 2.5, right in there. And it's going to be equal to 0. A lot of people, for whatever reason, somebody's teaching them to say MKZ equals and then start writing a thing. Do not do that. And tell me who's the teacher who's doing it to you, because I will need to have a conversation with them, because it's not right. It just leads people astray, and you'll make mistakes. Here we're being methodical and going through with the proper way to do things, so let's make sure that we follow through with this. Now we can go ahead and say MKZ is equal to, and if we take this and this together, we're going to see that we're going to get a positive answer, and it should be 2,547 inch pounds. And is it too early to try to turn people on to the Hewlett-Packard system? Is it? I don't know. Hewlett-Packards are great calculators. It's a great company, and engineering calculators, real engineers, you'll hear people say this all the time, a real engineer uses a Hewlett-Packard calculator, and they don't have an equal sign on there anywhere. It's something called reverse Polish notation, and it is superior to what our standard calculators do. And the idea is we have like a little stack that goes right in there, and we enter numbers in, and then we perform an action onto the numbers. Instead of saying 2 plus 2 equals, we go 2, enter 2 right there. There's a guy in the stop stack right here, and the bottom stack, and then we go plus, and that's the answer right there, right? So we performed an operation onto the thing. So anyway, just checking my numbers right here. Let me go for sig figs and all that kind of other goodness too as we're going through this. So we had 370, enter 5.6. I hit multiplies. Boom. And that's what those guys are to each other. And then I have 190, enter 2.5 times, boom. And that answer that I just had a second ago was still in my stack. That answer that I just got is in my stack. I just had to hit now plus. And now they're added together, and I got to 2,547. 0.0 apparently. So we only need 4 sig figs when to do calculation, but a minimum of 4 sig fig to do calculations, minimum of 3 sig figs for answers, right? But no more than 4 sig figs for answers. All right, so let's do the other views on this. Let's take a look at the, let's go for the YZ, right? So we're going to look down the length of the thing. Our big eye is looking in that direction, and we're going to down the X to see the YZ. So we get an FBD. I'll put them over here. Y is upwards, Z is to the left, just like it looks like right there. And we're going to see this big circle. And we're going to see this upper thing going on right there. And we're going to see this little side arm right there. So looking at the forces, we see the 200 is going to the right. It's in the negative Z direction, so it must be going that right there. So 200, did I say 200? I meant 220. This one's coming down. E's 370. We can't see the 190 because it's coming at us into the page. We put the reaction forces on here. I'll put a reaction force. Here we go. Here's R. RY. We have another reaction force. RZ. Don't need to do the calculation of them. they're obvious onto the thing. But now we want to say something here. That one's going clockwise. This is going counterclockwise. So we don't know which way the reaction's going. We can't predict for sure. But let's go ahead and put on our reaction. Now we can put, I'm going to go with its capital T again. It's torque. Why not? Might as well, right? I don't use capital T for anything else, just torque. So I'm going to go ahead and use it. I don't use it for tension. I don't use it for kinetic energy, which is just a dumb thing dynamics do. But use it for torque. And I treat it as counterclockwise by default. So now I go, sum of the moments about the x direction is equal to 0. Positive is counterclockwise. Oh, I didn't put my dimensions on here. That's a good thing to do. All right, so the dimension that I care about between here and here, that's the 4.8. And I stopped using my straight edge. I should use a straight edge. It'd be a good example, huh? Right, and remember, it's just the center of the thing, right? So I didn't really draw the centers in very well. There we go. All right, and then and maybe even put little arrows in there. The neater the sketch, the better. In fact, I'm kind of trying to cram this stuff in here. It's better to just use more space than to try to cram too many things in here. Okay, and then so what's the distance between here and here? That's 2.5. It's the distance we care about. So 2.5 inches. And I got my arrowheads a little too close to each other. I don't like that. All right, so anyway, let's continue on with the calculation here. I have my equations near my diagram. So I'll start out with a reaction right here. I chose positive T is how I've drawn the thing. And then I have a positive 370 times the 4.8. But now I have a negative, because this is going clockwise, 220 times my 2.5. And what do I get here? Let's do the thing out with our reverse Polish notation. That's what it's called. I didn't invent that. And we can't even see this stuff because of the light. I need to move that light. Now it's giving me this weird looking glow onto there. 370, 4.8 times, all right, and then 220, 2.5 times, but I'm going to subtract that out. Okay, so I get a positive 1,226, but that's on this side of the equal sign. It has to go on the other side. So we're only going to get it a negative 1,226. Did I get that one right? Yeah, I sure did. Inch pounds. So we don't want to draw an arrow in the minus sign. So we go 1,226 inch pounds clockwise. Right there, right? Remind ourselves. And then the last one we want to do, right? We need to look from above. And so when we do this, we declare that it's an FBD. And then we want to have in the X, right, we're seeing X and then Z. So Z goes down right there. And so looking down at this thing, we see this has this length. In fact, we could actually make it right below this if we wanted to. If we want to make little draftsman little thingies going on right there. Right? You see what I mean? How they're aligned with each other. And then you could say, that for this top view right here, you can see that circle that's right there, right? And then you're going to see this guy coming downwards, and it's going to be aligned with that, right? Almost too big, though. So I care? I don't care. Do I care? I guess I care. I guess I do, because I'm doing it. All right, sure. All right, so let's take a look at the forces that we see onto this thing. We can't see that force. It's right there. It's going downwards. But we can see that force. That's 190 pounds. And we can see that force, which is coming in the negative Z direction, of 220 pounds. And we want to have some dimensions that count. So this one is passing through. We're going to take the reactions about like right in here, right? So this one passes through there, so it doesn't really have a moment arm we care about. But this one has a perpendicular distance that's right there. That's going to be 5.6 plus 3.7. And so you could go ahead and do that in your head if you want to. Did I do it in my head? 9.3 is what I said. Is that true? Yeah, 9.3 inches. Right in there, okay. All right, and we don't really need any more dimensions onto this. We do need to put in our reactions. So we have a reaction in the x direction, which is our Rx. And we have a reaction in the z direction, which is coming this way. I'm going to put it this way, Rz, right? And then our moment, let's see, which way does the arrowhead, should the arrowhead go? This is going counterclockwise, so this one should go clockwise. And what did I say? I just decided to call it MKY, right? If I'm going to be trying to be consistent with the thing. So I go, the sum of the moments about the y-axis is equal to 0. And I drew this one as a negative MKY. And this is a positive plus 220 times my 9.3. So my MKY is equal to 220, enter, 9.3 times 2046. 2046 inch-pounds, and that's clockwise. Okay, so these are the reactions that I get onto the thing. But I was asked to get the equivalent moments and forces and put them onto a stump right here, all right? So for the forces onto the thing, they just get transferred over here. So that was 190. And we had 220 in the Z. And we had 370. I like to draw them if I can, like moving away from the thing instead of pointing towards it. I mostly want to try to get some space out there so that I don't get it too cluttered when I put the rest of the stuff on here. Now, let's see, about the x-axis, we said this was going to be clockwise, right? But it clockwise, right? That's the reaction. It ends up being clockwise. But so the actual application of the thing is counterclockwise, which is right hand rule, your thumb going that way, pulling that way. So if we're going to draw the correct arrow, it's just like our fingers would curl. That's it right there. So that's 1,226 inch-pounds right there. Let's do it about the z-axis here. That's counterclockwise. Therefore, it's going to be clockwise onto the stump, right? So counterclockwise is this direction. So it needs to go the other direction, or you could point your thumb and come this way right here. So here is clockwise right there. Or I could have put it over here. Maybe I'll put it over here. It's just that I like to put the number near the arrowhead, right? So that's going to be 2,547 inch-pounds. Did I label it? I think you can tell that. I might have wanted, I could have put this up here above there, and I think that could have communicated. So you want to communicate it to other people. Also, you want to communicate it to yourself when you go back to go look at the thing again. And then lastly, we want to have what did I limit? I'm going to look at the Y, right? So we decided that's going to be clockwise here. So it's got to be counterclockwise in the Y. So the positive counterclockwise with your thumb going up in there is about that direction right there. That's the that's the counterclockwise in the Y direction. So that's the 2046. inch-pounds. There you go. It's a problem where we've done it, to try to reinforce this method. And hopefully you'll get a hang of it. And if you have any problems with it, we'll just do some more problems together. So thank you. And that was the third video of the year in 20 minutes.